Hello, everyone. Welcome to the Geek Native podcast. This is another new episode where we are going to talk about another very interesting topic. This topic is a little unknown, it's not widely known among developers, but I find it very interesting. And it is about software bill of materials, also known as SBOM. And we are also going to talk about how do we use SBOM. First of all, what is SBOM and how do we use it, and why is it relevant at all to the developer community? And as always, I have a very special guest to talk about SBOMs and all around it. So without further delay, let's welcome Barak from Scribe Security. And he's a developer relations advocate, and I'm really excited to have him on this episode. So, Barak, let's start with a little bit of introduction so our audience can know more about yourself and about your role.
Sure. Well, like you said, I'm a developer relations advocate. That means that my job is to explain what it is we do, why do you need our product, and why our product is good for you. I'm not a salesperson. That's a very important distinction.
Yeah.
My job is not to try to sell you our product. If you tell me that you tried our product and it's not good, I say, great, tell me what the problem is. We'll try to fix it.
Yeah.
I feel much more comfortable in the position of being somebody who educates and explains rather than trying to sell you something that you may not even need. So my background is as a developer. I was an ERP developer. I was a full stack developer. I actually came to this company to be interviewed as a developer, and when they heard me speak, they asked if I was interested in the job as a DevRel. I said, I don't know what that is. So they sent me the specifications, and they hired me. So here I am. I've only been doing this a few months, but I really enjoy the challenge of explaining complex issues, complex ideas in a comprehensible manner.
Interesting. And thank you very much that you are here with us to explain the complex subjects in easy manner, because this podcast is all about understanding those complex technical concepts into simple ideas and be more curious about it. So this is not like a tutorial where we explain things, but it's more like food for thought and for some pointers that you can be more curious and go and search more on the topic. So that's the idea. So great. So let's start with our topic, which is SBOM. So to be honest, when I initially chatted with Barak, I was not sure what SBOM is, and when I searched about it, it is an interesting concept, and I don't know why it is not widely popular. So let's start with understanding what is an SBOM and what does it stand for.
An SBOM stands for a software bill of materials. Like any bill of materials, the same one you can find a driver handing you when a delivery truck shows up at a warehouse. Like any bill of materials, it lists those materials or pieces of software in a software artifact or a library. The difference is that as a software bill of materials, it can obviously hold much more information, be much more comprehensive. It can include much more. But if you are looking for a simplified explanation, when you go to a supermarket, you look at a cereal box. If you turn it around, there's a list of ingredients. That list of ingredients is extremely important. It can tell you if you're allergic to anything, if there are any problematic ingredients in that box. A software bill of materials basically does the same thing for software artifact. It can tell you if there are any problematic ingredients for you. It can tell you exactly what's in there so that no matter when you look at that bill of materials for that software, you'll know exactly what's in there. When I say exactly what's in there, that's the sticking point, because most software these days is using tremendous amount of open source. And those open sources, libraries or folders or whatever you want to call them, also use other pieces of open source, and so on and so forth down the line. And even though you might be able to look at what it is you're including and what it is they're including, at some point you're going to lose track. And tools like the SBOM, which are breaking everything down all the way down the line, are extremely useful because first of all, they save you a tremendous amount of work. And second of all, they give you a lot of visibility into what it is you're actually included in your software, what it is you're shipping out. It not only gives visibility to you as the software originator, it also gives peace of mind, hopefully, to the people who are going to use that software. particularly because some people might have problems with some of the things that you have decided to include, which are not a concern for you. Some people might have a problem with particular developers because they fought in the past. Some people might decide that a certain open source libraries would never set foot in their project or in their system for whatever reason. So knowing exactly what it is, all the components in a software artifact, is very useful for a lot of reasons for a lot of people.
Very interesting. So if I have to summarize in just one line what you said, I think ingredients of whatever software artifact you are building itself explains SBOM, right? Like,
yeah, a full list of ingredients.
Full list of ingredients. So there is no hidden thing in whatever artifact you are trying to publish. So like we were talking before on this topic, and there was an interesting term that Barak mentioned, and it was a supply chain, like software supply chain, and we want to secure this supply chain using SBOM. So before we dive deep into that, I want to understand, what do we mean by software supply chain?
Sure. Well, I already touched on it a little bit. I said that we're using open source, and those libraries are using open source, and so on and so forth. So if you imagine it as a sort of chain, then you can think of those libraries who use libraries who use libraries and so on recursively as links in that chain. Now, when you think about the visibility, you can look down 1, 2, 3, 4 layers. But some of those layers go down so deep that it's almost impossible to dig all the way down, especially because some people don't even take a full library. Some people just take code snippets or pieces, or go to various other places and take something that used to be this and now it's something else, and it gets very muddled very quickly. That's one way to look at the software supply chain. A different way, which is, again, it's still called software supply chain, is when your company or organization is using bits of software from other vendors. They have access to your system, so if anything would be compromised in that software, it's essentially based like a backdoor or a compromise into your system. Those two ways of looking at the software supply chain are both valid, but for our purposes, for this conversation, when I say software supply chain, I'll be referring to the dependency tree or the dependency chain of this endless loop of open source projects.
Yeah, very interesting. So yeah, I think you shared like two ways to look at this supply chain, and both ways are very interesting. So now, since we know what is an SBOM, what do we mean by a supply chain when it comes to the software artifact? How do we secure this supply chain, and what are we securing against?
Sure. Well, let's assume, it's an easy assumption, that there are some bad people in the world who want to harm your software for whatever reason, for money, for fame, because it's fun.
Yeah.
Now, targeting companies directly is hard. Companies have a lot of defenses. They have firewalls, they have passwords, they have a lot of different means of preventing bad people from interfering with their system. Going after a single developer's library, however, is a whole other matter. If there's a single developer or a small group of them somewhere out there in the world, and they have an open source library which is very popular, joining that group as a developer and making some minute changes to the code, that's totally within the realm of possibility. And then that little library is being included in lots of other pieces of code, and those pieces of code are included elsewhere, and so on and so forth. And suddenly, your little back door that nobody even knows about can be found in 18,000 different corporations, and you have access. That's one of the problems that has been demonstrated in the SolarWinds break-in. At the end of 2020, came to light that SolarWinds, which is a company very well known and respected, was essentially hacked. The final build on their server was modified, and all the builds that went out have been essentially poisoned. Nobody knew about it for a long time because it went out from the company server with the certificate. Everything was signed, everything was approved. Companies have been working with them for years. It's not like they're going to check every new version. New versions come out all the time. Once you verified the company, it should be fine. And 18,000 different companies have been compromised, including 9 different federal authorities, including the Department of Defense and Pentagon. That's a big deal. That's a problem. So that's the sort of thing that we're trying to defend against. When you don't know everything that is in your code, when you don't know every library and version, and when you don't know everything, you are essentially at risk of having one of these things happen to you. So an SBOM gives you visibility. That's the first thing. That's one of the greatest things it can give you. It gives you visibility into everything that is in your code. Every library, every version number, every license type, all the dependencies, all the different relations between everything. So that even if you don't have a problem now, if at some point some sort of problem comes to light, for example, this library is fine now, but in 6 months suddenly somebody discovers a new vulnerability that uses that library. If you know you have it, you know what version, you know where it is, it makes it much simpler to fix it. Instead of starting to scramble to take apart your code and figure out, do I have this? If I have it, where is it? What's the version number? Is one of our legacy systems have it? Is it one of our old servers? We don't know, because nobody knows everything. And the person who worked on that server has left the company 6 months ago. We don't know. Having a singular source of information that is constantly being updated, that gives you all that information, extremely useful, especially in such a case. So visibility is one thing. That's a very important thing. Trust is another. Trust is something that you can get by checking what it is that you now know you have. A lot of companies have a method in which the security people check in advance whatever open source packages their developers want to use, and they verify them. And that way, those developers are only allowed to include packages from the approved list. Having an SBOM means that some security personnel at the end of the day can verify that no packages from an unsecured source have been included. That's one way of checking it. There's many other different ways. But again, visibility is the beginning of this thing. If you don't have visibility, you can't run tests, you can verify, you cannot check. If you have visibility, you at least have options.
Yeah, very interesting. So it helps you make your system, or it helps you by giving you more visibility into your supply chain system, and it also builds that trust so that you can build the software with more confidence that nothing is going on wrong, and whatever you're changing is actually the intentional change that you want to make and nothing else, right?
I would also like to point out that it's not only giving you visibility and trust inwards into your organization. The idea is to spread that trust around. The idea is that you want to include the SBOM with your software when you're shipping it out so that your clients know what they're getting. The more people include SBOM with their products, the more visibility is shared among all of us. If you think about it, there are very few things that are a complete product in and of itself. If you think of a complex product, let's say a fighter plane, or a jet, there's the hardware, which is also comprised of many different parts from many different companies, and there's lots of software, also comprised of many different parts from many different companies. If every single one of them included an SBOM, that means that the final, let's call it the final link in the chain, the final company that puts everything together knows exactly what they have. If they don't, they have to trust you. And trust is a great thing, but without evidence, it's stretched a little thin lately. There's many examples of this. If you are, let's say, medical technology, you're a hospital and you're buying lots of pacemakers or insulin pumps. You have to trust the company that whatever software they've used is fine, that they don't have any vulnerabilities or exploits. But you don't know what's in there. You just bought it. You have to trust the company. If you had an SBOM and something new came to light, you don't have to ask the company, tell me, does your device have that vulnerability? You can look at the SBOM and know for yourself immediately. Yes, it does mean that companies would be more obligated to make sure that what they're giving you is good, tested, clean of vulnerabilities. But hey, I consider it to be a good thing. We need more of that in the world.
Absolutely. Yeah, so that, like, having an SBOM sounds like a great idea to build that trust and to also spread that trust among your users, and also to have that visibility into whatever you're doing. Uh, I think you briefly mentioned about what SBOM has, and it's not only like one type of dependency. So let's say if I have to talk about the dependency trees, if I have a, let's say I'm working on a project and I just create like a dependency tree using tools like Maven. So it tells me what dependencies I'm using. So I believe this is very limited to the dependency only, and SBOM is slightly like is like a superset of this, right?
SBOM includes many different kinds of information. There are at least three major types of SBOMs because we're trying to build standards, and each of them is slightly different, but all of them have, at a bare minimum, 7 pieces of information like names of packages, version numbers, a unique identifier of these packages, various things like that. But in terms of relations between different files, there are many different kinds of relations, and dependency is only one of them. If I remember correctly from the NTIA documentation that describes the SBOM, which is NTIA, for those who are not familiar, is the National Telecommunication and Information Administration in the United States, and they wrote the book about SBOM, at least the beginning of it, the idea of it. And in that documentation, they mentioned 43 different kinds of relations between files. And dependency is, again, only one of them. You can have a file that's created from a different file as a result of a test, or as a log file. You can have 2 files that have combined together to create a third. You can have files that have created a new file and then deleted themselves. You can have a lot of different types of things that could happen in the complex process of compiling your software artifact, whatever it may be. So knowing exactly how that software came to be, including all the files, some of them may have disappeared, new logs appeared, various other things happened. Knowing all of that gives you, again, all the information you need to, again, check, look, verify, do whatever it is you need to do to be certain that this new software that you're about to use or include into your system is fine with you, with whatever requirements you might have. Having a dependency tree is great. It's awesome. The more, the merrier. But having more information is better.
Yeah, that's very interesting. I'm just being curious here. Like I said, like as I initially said, I didn't know about what is an SBOM. So, what is the history of SBOM, and why are people not aware of it?
Sure. If I remember correctly, around 2008, 2014, they started talking about the SBOM as an idea. Before that, there were still people who wanted to know all the ingredients in their code, or all the license types, or all relations. And what they did is they worked manually. They were people in dev or security or whatever department they happened to be in, whose job was to go over their systems and document it so that if anything happens, they know where everything is.
Yeah.
But that's a really tedious, job. First of all, it's boring and repetitive as hell because things keep changing. So no matter when it is you think you're done, you have to do it again and again and again. It never ends. It's the very definition of a never-ending labor. So the idea was to create an automated system or an automated standard that would include that and could be run automatically. And the logical conclusion of this was that if you have an automated system that can do that, you could also have an automated system that can read that, look at that information, and start making decisions. That, removing the human element from the equation, making it far easier to share information between different companies, to have decisions being made based on that shared information. Only recently, I became aware of a new standard that they're now developing for how to share SBOMs in a very, very efficient way between different companies. Because again, of course, you can send an SBOM through email. It's a file, after all. And you can obviously save it as a file in a folder. But having an automated way of sharing an SBOM automatically every time that you're creating a new a new software artifact, because CI/CD implies continuous. That's the whole point. So doing it automatically, continuously, sharing it automatically, continuously, and documenting everything that you're doing, everybody's doing. The more automation in this whole process, the better. So again, the idea was to replace that old manual way of doing things with a more automatic, machine-readable way. And of course, if you think about it, the natural conclusion of having a full buildup of a software ingredients, including version numbers and names, is that if you have a parallel database of vulnerabilities, you can start making comparisons. And that database is now, being built, and the connection between that and sharing SBOMs is slowly being, codified. The vulnerability exchange exploit, I don't remember the full name, but it's called VEX, and it's currently under construction. And again, the idea is that automatically, in a machine-readable way, you can share SBOMs and automatically scan them for vulnerabilities and exploits.
Yeah, very, very interesting. I think, so I'm again curious on the vulnerability part, but I would like to understand, like, where does it fit in the regular software development life cycle?
Sure.
Since you said that, like, there can be like automation tools which can just compare two SBOMs and figure out something is wrong or not matching. So where in the software development pipeline does SBOM fits really well?
Well, the logical place to put it would be just at the end of the pipeline, right after or right before you have a full software artifact that you're ready to ship out. That's the logical place to put it, because that's after everything that needed to happen already happened. If you want to be extra secure, you can create multiple SBOMs along the various stations of your CI/CD, just to, let's say, to make sure that nothing broke after tests, or that nothing untoward happened between your repo and your testing and then your build. You can do various things, but again, most of it is for you. If you want to give an SBOM with your software artifact, the logical place would be at the end. Your clients or users wouldn't be interested, or they might be too interested, in the software bill of materials of your repository. But what you can give them is a software bill of materials of the final product, and they can look at it and decide for themselves whether or not it's fine and they want to use it. So the logical place would be at the end of the pipeline.
Yeah, very interesting. I think that makes sense. And so you previously said that this should be like a continuous process, that you create SBOMs, you maintain like different versions of SBOM. If there is a need, you can also compare them. How continuous should it be? Like every small change that I make, should I create an SBOM?
Okay. Every time you create a software artifact, which is usually every change you make to the repository, should have its own SBOM. Because again, an SBOM is a full list of ingredients. If you changed an ingredient in any way, you need a new list. And one of the things that an SBOM includes, which is incredibly useful for security people, is a hash of every file. Every change you make to a file, hash changes. Having a list of hashes is incredibly useful because you don't need to look at the code. You can look at the hash, compare the hashes, you know they're identical. If the hash changed, file changed. Now, if you change the file and the hash changed, everything's fine. If you don't think you changed the file but the hash changed, something is suspicious here.
Yeah, that makes sense now. So going back a bit to the vulnerability part, I think you briefly touched upon like a practical example of the vulnerability. But let's take another example. For example, the colors vulnerability, right?
Yeah.
So I want to understand that how SBOM could have helped before the vulnerability was injected and after it happened. So how could it have been better if I had a SBOM?
Okay. Well, the problem with colors was that the developer of this open source library has been, decided he's been fed up with the way corporate has been using his work without any sort of recompense. He was really annoyed, so he put an endless loop into his library, and pushed a new version into NPM. Since new versions are constantly pushed, and he's the originator of this library, there's no problem. Any software that didn't set a version number got this new version, which means that come morning or come next update, a lot of people, a lot of companies found out that their product was no longer working because there's an endless loop somewhere in there.
Yeah.
Obviously, that is a problem. We don't want our code to break because an unknown update has suddenly included a loop into our build. Now, once this was discussed in the news, people could start looking for if they had that particular dependency. But again, Colors was incredibly, probably still is, incredibly popular. It's downloaded several million times a week. So figuring out exactly where it is in your code, which versions, and again, you might have multiple versions, multiple places. That's a huge task. If you have an SBOM, you can run a search. You know exactly where it is, how many times, the exact or relative location or path into that particular library, and which versions of that library are everywhere. So after you discover what the problem is, you can look. If you don't know what the problem is, but you know something changed, you can compare the broken SBOM or the broken version of the code of the SBOM of the code with the previous one and see what changed. Probably a few things changed, but it will definitely give you a short list of changes that you can compare and figure out what the problem is, rather than looking at everything. Looking at everything is a big task. Could take weeks. Looking at a short list of, let's say, 5 or 10 different libraries, much more manageable. It changes from a few weeks to a few days or a few hours. Now, again, looking at your problem if you don't have an SBOM at all, that could take months. Because again, you might not even included colors in your code at all. It might be a dependency of a dependency of a dependency of a dependency of something that you're not even aware you have. So digging that deep into your code to figure out where it is, what version it is, it's almost scary to think about. And I know that for a fact, a lot of people have came into face to face with that problem when the famous Log4j made its debut into the world. At the end of last year, a lot of companies started scrambling, trying to figure out if they have Log4j. They probably did if they're using Java. Which version and where? And if they have multiple versions, they probably do. Again, where all of them are, what all the versions are. Knowing what it is, where it is, and what version is a huge task. It's incredibly complex, especially the more complex your product is, obviously the more complex it is to try and figure it out, especially if you have a legacy system, especially if you have multiple systems, and you're trying to figure it out on all of them. So again, in all of these cases, having an SBOM with a comprehensive list of everything you have, versions, paths, everything, makes it so much simpler to figure these things out.
Yeah, I think that's a great point, that it will help you figure out what's wrong very quickly as compared to like spending days just finding out even if we are using it or not. So yeah, that's a good thing, and I think speed makes a big difference when it comes to vulnerability, right? Like we have to act fast and do something about it. So
speaking as a developer who got more than one phone call of, oh my god, it's not working, fix it, because our clients need this now. Yes, speed is incredibly important, especially when you are woken up in the middle of the night and you're still bleary-eyed and you have no idea where to start looking. You don't know what the problem is. So yeah, having a place where you can start looking, having some sort of thread you can start pulling instead of looking at everything, it's a big help.
Makes sense. I have a silly question here.
Sure.
I mean, it might be silly. I don't know. What happens? How do we protect the SBOM itself? So, what happens if the SBOM itself is, compromised?
An excellent question. It's not silly at all. That's where, since I come from the realm of cybersecurity, that's where digital signing comes into effect. The idea is that if you want to do things in the right way, you create an SBOM and you sign it. And only very specific people or the company itself as an entity has the ability or the permission, as it were, to sign that final SBOM. So that let's take a completely theoretical idea. Let's say you have a company, you created an image, you're very proud of it, and you put that image with an SBOM because you're very diligent in Artifactory. And you put it there, you gave it a name, you gave it a tag, everything is great, and you direct your clients to download that image and use it. Then somebody evil, maybe somebody evil who has access to one of your developers' computers, uploads a new image. Has the same name, has the same tag.
Yeah.
You don't know it was changed. How would you know? It's the same name and same tag. And now everybody who you sent to Artifactory to take that image is getting a bad image. Now, if you included an SBOM, which was signed by the company, nobody could nobody could fake that, hopefully. If they stole your certificate, there's a whole other can of problems. But if your company has a certificate, or if somebody on your company has a key that you can sign that SBOM with, nobody can change it. So now you can compare that SBOM with the image that is there. And if it doesn't fit, suddenly you're aware there's a problem. And you can do that with a lot of other things. There's a lot of new, or relatively new, frameworks out there currently in discussion. Google Salsa is one of them. And one of the mainstays of Google Salsa is provenance, where files come from. Having a provenance file describing how that final artifact came into being, where all the files came from, everything that happened along the way, and having it signed, that is an incredibly important way to basically secure both your development process, if you are following everything in the way you should, and your final product, because having that signed evidence means that nobody has to take your word for anything. They can just check the signature, check that SBOM or other type of evidence like provenance or attestation, whatever type of evidence that you're including, and make sure that what you're saying is indeed the case. So yes, signing SBOMs is definitely the right thing to do.
Yeah, that makes a lot of sense. So I just realized it was not a silly question.
No, it's not.
Question.
Because assuming that people are good and kind and want to help is one of the cardinal sins of a lot of developers. Knowing that there are bad people out there is something that we're constantly have to be reminded of. Because why would they want to break our code? But yes, some people do want to break your code, even if it's just for the laws. So we have to secure it.
Makes sense. Is it more relevant to the open source software that we consume, or it's like equally relevant to also the proprietary software? So is there sufficient trust out there that is lacking in the open source world, or
that is a more political question, I think, than a security or a code one. Personally, I have a feeling that after the events of the last couple of years, trust is thin in everything. Most people would have a problem trusting corporations because corporations are evil, I guess. The open source community has recently been doing more, let's call it hacktivism, exactly like the example of colors. There are other developers of open source who decided to poison their packages specifically against Russia because they're supporting Ukraine. Lots of different examples of people who were fed up or annoyed or angry or had an axe to grind with somebody specific. So yes, trust is thin in everyone. So I think that the correct answer is don't trust anybody, include the SBOM with everything, and let everybody make their own decision based on actual information. If the SBOM, the more widespread the SBOM will be, the more informed decisions everybody can make about what software they want to purchase, what software they want to incorporate into their own system, and so on. So I would not cut off or prevent anybody or recommend that anybody is prevented from using an SBOM. Even the United States government, or I don't know, any other government or bank or anybody. Don't trust anybody. Ask for proof always.
Yeah, that makes a lot of sense. Yeah, I agree. Great. So I think just to summarize what we have discussed, there were so many important points. First is like we understood what is an SBOM, why do we need it, what is a software supply chain, how do we secure it, what is the place where creation of SBOM makes sense, how frequently do we create an SBOM, which is like every time
Yeah.
you make a change.
Yeah.
And no matter how small is the change, you need to create an SBOM to be completely secure.
Yeah.
And then securing the SBOM itself using the digital signature is very important. And yeah, so don't trust anybody. So ask for evidence. So
Yeah.
I think those are. Did I miss something?
No, I
Or
think you
that
got it, everything. Yeah. Just
is
one thing else I would like to add. We're constantly talking about an SBOM. Obviously, that is incredibly important.
yeah.
If our listeners don't remember anything else, remember SBOM. Go look at it, check it out, ask for it from every vendor or software source, or ask for it for everything, from everyone. The more people ask for SBOMs, the more people use them, the more people will have to give it to them. And the more widespread they become, the better it is for the entire ecosystem. We want more SBOMs everywhere.
That makes sense. Yeah. Great. So I have another small question before we move on to the other section. Who like who should be worried about or concerned about the SBOM? Is it the developer, or more for DevOps or SREs? Like, what is the role that should be concerned about SBOM, like creation of SBOM and maintaining them?
Well, since we mentioned that the logical place to put the creation tool for an SBOM is at the end of the pipeline, usually the people who deal with automation and pipelines are the DevOps or SREs. So that would be the first thing that I would look, especially if it's a big organization, multiple pipelines, lots of testing, lots of repositories. They probably have either a single DevOps or a department of them to deal with automation, so that would be the logical place. However, if we're talking about a smaller, operation, only a few developers, maybe even a single one, they don't have necessarily any sort of automation tool. Maybe they have a simple GitHub Action CI/CD pipeline. Maybe they don't have anything, and they can also do that manually. In that case, you can always create an SBOM manually every time you compile your artifact. It's just more work for you. But the idea is, again, that the more artifacts are out there in the world with an accompanying SBOM, the better. I wouldn't circumvent that requirement from anybody, no matter how small their their company or artifact is, because our aim here is to increase visibility. And when you want more visibility, you can't let anything, even as small as a single file or a single library, go unscathed, because then you're just opening the door for the possible injection of vulnerabilities somewhere down the line. Everything should be documented. Everything should be, as fully documented as possible. So yeah, everybody should be doing it. Logical place is, again, SREs or DevOps in the end of the pipeline. If you don't have a pipeline, if you don't have an SRE or DevOps, do it yourself.
Yeah, that makes sense. I was also wondering, since we are creating, so it's like a continuous process, and we are creating an SBOM every time. Is it so? Of course, we never trade off security. So I was talking about the latency in terms of shipping our software. So is creating an SBOM, since it is creating it every time for each of the dependency, is it an expensive operation,
No.
or it's just fast enough?
Well, it's not expensive. It can take a long time. It depends on the complexity and size of your artifact. That makes sense, because basically you're breaking it down to its constituent parts. So the more complex, the bigger it is, could take longer and be more complex. But essentially, it's no more complicated than the compilation or build process itself. And if you do them simultaneously, if you do it at the same time, I don't see it as being that much of a drain on your system. You're already building it. You're already doing it as we're speaking. Don't wait until after it's done and then say, oh yeah, I need to build an SBOM and start the whole process again. Do it at the same time as part of the process. So, it might give you maybe a little bit slower, maybe a little bit more resources, but I think the reward is worth it. And in terms of, again, shipping out, the whole idea of continuous integration, continuous delivery, you want it to be continuous. So you want every change to be uploaded to your I don't know, Artifactory or wherever it is that you're hosting your artifact or your program, obviously now, after this talk, hopefully you want it to be there with its accompanying signed SBOM so that anybody who's going there to use it, to look for it, to incorporate it into something else can verify that what they're using is indeed what you intended for them to get.
Yeah, so that makes sense. And yeah, I also think that since we are already building that, artifact, doing it along with this process shouldn't take a lot of time, and it shouldn't like impact your latency such that, and of course, security is the highest concern, right? That makes sense. Um, let's talk about some of the misconceptions around SBOM, that because since it is not widely popular, there might also be some misunderstandings, like what is SBOM and what is the effect of having an SBOM.
Sure.
So what are the misconceptions?
Well, one of the most common misconceptions, usually held by bigger corporations, is that having an SBOM would essentially invalidate their IP, their intellectual property. That giving away an SBOM with their product would essentially enable anybody who looks at that bill of materials to recreate their product, thereby making them, without value. That is, of course, not true. An SBOM does not include any piece of code whatsoever. All it includes is file names, library names, and versions. It includes hash files or hash values of files. It doesn't include any code. And the way I like to explain it is that looking at the ingredient list on the back of a cereal box doesn't mean you know how to make cereal. You can't make it alone at home. You know what's in there. You can't make it yourself. The same is true for a software artifact in an SBOM. You'll know what's in there. You might even have some idea about how some of these elements came together, or the environment in which it was constructed, and other pieces of information like that. It's very useful. But I doubt you'll be able to manufacture the same sort of artifact yourself, because you don't have the code. You don't know what's in those files. And if, for some strange reason, some company has a file name that says, this is our secret recipe, do not copy, they might, consider changing that file name into something a little less conspicuous so that they don't paint a big red target for anybody who wants to look for that file that says secret recipe.
Makes sense. I think, yeah, that is a misconception I also had initially when I started looking at what is an SBOM, but it makes sense because there is no code. It's just like an artifact of all your dependencies, all not only dependencies but other types of
all your files, how they relate to each other, and your dependencies and how they relate to each other. Everything that was compiled during the build of the final artifact. Your source code is in there somewhere, presumably as well, not just dependencies. But again, only the file names, not code. So one would presume that, for example, if we're talking about NPM, package.json would probably be in most of them. Or, index.html would probably be in a lot of different artifacts. But that doesn't mean you know what's in there. You don't know what is written in the package.json. Well, you would if you look at all the dependencies, but you wouldn't know what is written in the index.html file. You don't know, what it's connected to or where it's leading to. You don't know what's in the files. You just know the file name, version number, and how it relates to other files.
Great. Yeah, that makes sense. What are the limitations of an SBOM? So as of now, what is that one thing or certain things that SBOM is not able to provide us?
Well, all the examples and talks we had so far was for one big software artifact. That you have this big artifact or image that you can break down and know everything that's in there. But a lot of software these days is not built that way. That's a relatively older way of building something. These days, more and more companies and services are being built on a cloud platform in a multi-service way, completely separated. Everything is microservices with lambdas, possibly machine learning, AI. Everything is so separated, there's no real easy way to break everything down in a single comprehensive file. An SBOM can run on any software artifact, but it currently is unable to run on a completely unharmonious or completely disjointed system. It wouldn't be able to run on all your microservices and make some sort of coherent image out of them. Because they're not built in a coherent way. Only the people who built them know how everything relates to everything else. It's a very complex web, and an SBOM currently doesn't know how to deal with that. People are constantly working on it. The idea is obviously to be able to break down any sort of system and have that same information. But at the time we're speaking, the SBOM doesn't know how to deal with that.
Okay. Yeah, I hope these things are available in the future. Talking about the future, since we are trying to create this this awareness of what is an SBOM and why is it important, what is the future for SBOM? So from two perspectives, right? One is from the developer community. Like, do you see that more and more people are now looking at SBOM, like having an SBOM and adopting that process? And from other perspective, how this creation of SBOM process itself is going to evolve?
Well, speaking after looking at the recent or relatively recent regulations that are now coming into effect in the United States, I have a strong suspicion that the SBOM is going to become more and more prevalent, not only in the United States, but throughout the world. We have the executive order from the Biden administration, 14028. There's NIST's SSDF, the Secure Software Development Framework. All those things, both these things mention SBOM by name. And we want more companies, we want everybody, not just companies, to include SBOM with their final artifact. The more, like I said, the more people, more companies, more entities include SBOMs, the better for everybody. In terms of people who use it, again, if everybody asks for it, if it's widely available, everybody can use it. You can have automated tools that immediately, with every update you get, with every piece of software you get, immediately scan the SBOM, compare it to a vulnerability database, check if anything is wrong, and you would know that even before you would get that update. You don't even have to check. You immediately get the SBOM is scanned, compared to a database of vulnerabilities, you get that immediately. It obviously goes the same for every update you ship out, for every open source package that you want to use, everything. Again, the more widely it is used, the better. It will be machine readable, immediately scannable, immediately comparable with both vulnerabilities and exploits. And since that database would be updated very quickly, and you would have SBOMs for everything that you're using, including your own software, whenever it's only depends on the speed of how often do you want to make those checks. So let's say something is updated in that database, you can get an immediate alert. Listen, your software has that version of this package. You better want to do some remediation, or the package that you're considering to include, that open source, has some dependency that has now been discovered as exploitable. And again, those things are completely doable even now. It's just a matter of getting SBOMs more widely adopted. The more widely they're adopted, the easier it will be for these kind of automated tools to be widespread and included everywhere. It will make all our lives better.
Yeah, that makes a lot of sense. So I think we have covered like SBOM pretty extensively. Like, there is a lot of information that we have added around understanding SBOMs, and at least make the viewers more curious about understanding it and adopting it eventually. So I think, did we miss something? Do we want to add more to it, or I think it's a good enough?
No, I think for a starting info dump, it's a good place. There's obviously a lot more information. There's a lot of tools. Yeah. Basically, you can look at any of the three major types of or standards of SBOMs, decide which one it is you want to adopt, and go from there. The three, since I didn't mention them before, are Cyclone DX, SPDX, and SWID. My company's adopted Cyclone DX as our standard. I would recommend, if you, for example, want to use that standard, going to their website, checking whatever tools they have. They have both open source tools and tools which are obviously, for pay, and start playing with them. Start using them. Obviously, the free ones. Don't pay for something you're not sure about yet. Start using it. Start experimenting. See what it can give you. See what information you have. And there is one other thing that we mentioned that we have not covered. I did mention that the SBOM includes the package or package name, the version, and the type of license. License in poisoning is something that is well known among bigger companies that are using a lot of open source, because there's a lot of different open source licenses. Some of them specify that any software that includes that open source package has to be open source. So if you, by accident, including that package in your software, you can't sell it anymore. It has to be free. It has to be open source. So legal departments everywhere are constantly digging through code to make sure that everything is fine with them in terms of licensing agreements. And again, knowing all the dependencies of dependencies is a huge undertaking. So having a very convenient list of everything in your software, including version numbers, including the type of license, makes that a lot easier. So you can verify that you didn't accidentally invalidated your company's IP by making it free because you wanted to include another easy-to-use library in your code.
That this information is enough to spark the curiosity among the viewers, and they can always go and find more information. I'm going to attach a lot of links and references on learning more on SBOMs and the tools available. So please take a look in the description, and please subscribe to the channel and smash that like button if you enjoyed this discussion, and if this discussion was able to spark that curiosity among yourself. So yeah, thanks a lot, Barak, and I really enjoyed the discussion. I learned a lot, and I'm sure our viewers will learn a lot as well. So
You're
thank you so
very
much.
welcome.